This video covers section 8.3, an introduction to functions. Objective 3, determine whether a relation expressed as a graph represents a function. When we graph an equation, we end up with a set of ordered pairs, x, y. We've seen that each x in the domain can only correspond to one y in the range in order for it to be a function. The easiest way to check this is by graphing the equation. We've seen that in a mapping, if A corresponds to x and y, then it's not a function. If A corresponds to x and B also corresponds to x, that is a function. Each x in the domain can only correspond to one y in the range. The easiest way to see this is by graphing it. If we have a set of ordered pairs where 1 is related to 2 and 1 is related to 3, when we graph that 1 is related to 2 and to 3, then a vertical line will cross in those 2 points. And this is an example of something that is not a function. If we have 1 that goes to 2 and 3 that also goes to 2, that is something that is a function. 1 would go to 2 and 3 would go to 2. That's fine. So we're looking for 2 points in which a vertical line crosses it. That's not a function. But if a vertical line never crosses 2 points, then it is a function. So we say that it's the vertical line test. A set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most 1 point. So this is much easier to see with a graph staring at you. Practice 2a, we could get a vertical line right off the bat to get that one to cross in 2 points. This means that each x has more than one y associated with it, so this is not a function. Whereas every vertical line crosses this one in one spot, so this is a function. Sideways parabolas are not functions. This is not a function because it crosses in more than 1 point. Lines are functions. Most lines are functions, I should say. A line with negative slope, a line with positive slope. But a vertical line is not a function. That one vertical line crosses in many more than 1 point. So this is not a function. So to determine if the equation is a function, we'd like to graph this. And so what we've seen before is that y equals x squared is the graph of a parabola opening upward. And every vertical line I draw will intersect it at 1 point. So this is a function. And we've seen the graph of x equals y squared is the parabola opening to the right. And we can find at least one that crosses in more than 1 point. So this is not a function. Graphing y equals absolute value of x. When x equals 0, the absolute value of 0 is 0. When x equals 1, the absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of negative 1 is positive 1. And the absolute value of negative 2 is positive 2. This is an example of a function. X equals absolute value of y. When I plug in negative 1, then x is equal to the absolute value of negative 1, which is 1. So that point is 1, negative 1. If I plug in y equal to 1, then x is equal to the absolute value of 1, which is 1. And so this is also, or this is the point 1, comma 1. The first one is 1, negative 1. And the second one is 1, 1. We have the x value of 1 that corresponds to two different y values of 1. This is a V graph that opens to the right. And so this is not a function. And this concludes the video for section 8.3, an introduction to functions. Objective 3, determine whether a relation expressed as a graph represents a function.